Hey guys, and welcome to another video in this artificial intelligence tutorial. In this video we're going to talk about like the need-based classifier that we talked about in the last video, where it was more just kind of like a hello world program for artificial intelligence. And I really wanted to go more in depth with the classifier and also show you like just like how some of the functions work and how we can code them in Python, because like some of the functions and methods and like the concepts behind the need-based classifier, it also like can be used to other classifiers inside of like machine learning and artificial intelligence. So let's start with some code examples here. And in the first example here, we're importing like the first lines of code here. We're just importing the libraries that, or like the packages that we want to use, and we want to use like some random numbers and math and a CSV reader. So the first function here is just like how to load a CSV file, because our data set here is stored in a CSV file. So we want to create a function here where we just pass the file name here as a parameter, and then we want to like get that data into a list in Python. So we do it with this function, which first check if the file can be opened and read. And if we can do that, we just read in like CSV reader. We call this function reader, and then we just read the file and store it in this CSV reader variable here. And then our data is stored in rows, so this row corresponds to one iris, and the next one here like another iris. So we want to go through all the rows in our data set, which we read in here to Python as CSV reader. And if we go to the end of the data set, it will just continue and it will go out. So if there's something on the row, we just append that row to our data set, and then the data set is a list that we can return from this function. So this function just like takes a CSV file and converts it to a string we can use in Python for a data set. Then in some cases we also need to like convert a string to column or like not to a column but like to a float or integer, because the last column here in our data set is the category or name of the iris of the flower. So we just give it a parameter here like the data set, and then the column that we want to convert from a string to a float. And then we just like cast it directly by calling this like function or casting method here, which we call float, and then it will convert that string to a float. And yeah, that's just how we do it. And also with the integers down here, just like kind of the same. So when we're testing and training our classifier here, we need to split our data set into k folds, which means that if we, for example, let's say we have 150 data in here, like rows of data in here in our data set, then we want to split them into like some of them we want to train our model on them, and some others we want to use for validation, because we can validate on data the model has already seen, because then it will not make it reliable and the predictions will not be like it will be accurate, but it will not be precise to predict on data it hasn't seen before. So that's why we're doing that. So we're just creating this function here called cross validation split, and we pass the parameter that is the data set we want to split here, and then the n folds, which is like how many folds we want to split our data set into. Then we go down here and say like we just create a for loop here where we run from 0 to like the range of the n folds that we entered up here. So let's say we have like, for example, we entered 3 folds and we have 150 rows of data. Then it will mean here that if we go down here and say like the fold size is then 50, because we have the length of the data set is 150 and our n folds is 3, then the fold size will be 50. And then in a for loop here, we just run until like the fold is as long as the fold length of the fold is less than the fold size that we created that we initialized up here from the dataset and the n folds. And then we just take some random range, like we take our index will be a random row in our dataset, because when we're calling this function and several times and dividing our data into smaller data sets, then it will just randomize the data around. So let's go into the data here, like for example, like line 66 or row 66 will not be like line 66 when we have split our data, because we're using this random function here to index our rows, so it will just be like moved around and randomized the data. So that's why I'll show you later, that's why we get some different kind of scores if we try to run the program again and again. And then we just create our data split here, where when the fold is now greater than the fold size, then we have like split our data into the fold that we wanted, and then we just append that fold to our data set here and return that data set that is now split into a smaller data set, and also like a randomized data set. We can say it in that way. So when we created our model, we also need like some kind of way to to evaluate if our model is good. We can do it by like calculating this accuracy percentage here, and then we pass two parameters here. Like the first one is the actual the actual value it should have predicted, and then the predicted value that the model has predicted. And then we run through like a for loop here where we have I in the range of the length of the actual, so like how many actual values should have been predicted. And if the actual value is equal to the predicted value, then we just increment the correct score here by 1. So, and then we return then the correct, like the numbers of correct predictions divided by the length of the actual, the number of the actual values it should predict, and then multiply by 100 to get it in percentage. So let's say, for example, we have like 50 actual values that we should have predicted, and then we predicted, and then like we just predicted some values, and we go down here and say that the actual value here we predicted was, let's say, like one Irish flower, and then the predicted one was the correct one, and then we just increment it by 1. So in case the length of the actual list here is 100, and and we have predicted like 50 correct, and we calculated it with this line of code down here, then we'll get a 50% accuracy of our model. And in case we, for example, predicted 99 values correct, and there were 100 actual values, then we have a accuracy percentage of 99%. When we're creating our model, we also need a function to like evaluate our algorithm that takes in the data set and the algorithm that we want to evaluate, and then the end falls from before, and then also some other numbers of arguments if that's needed. So we go down here, and then we have our folds here, which is like the cross validation split function. We just went over up here, which returned the data split that is like the data set that is split, and then we just store it in a new list here where we go through all the folds in our folds, because we have like randomized data for each fold. So we go through them, and then we set them equal to our training set. So the data set we just split up is now our training set, and we go through all the different kind of folds in the folds. And then we just go down here when that is done, and we can say that the predicted value is equal to like the algorithm, and then to the algorithm function here we pass the parameter the train set that we want to the train set that we want to like train our algorithm on, and then our test set that we want to test, because as I mentioned, we're not testing on the same data as we're training. And then we can see here that the actual values are just like the -1 row in like row in each fold. So this is like a supervised AI like classifier approach, where because we know the actual value, and then we predict the value, and then we use this accuracy metric here as we just went over here, where we calculate the accuracy percentage. So the predicted values here will be stored in a list which are the predicted values that our classifier predicted, and then the actual values here are the actual values that should have been predicted by the model and the algorithm up here from this function. And then we just print like append the score, like the accuracy to the scores, and if we just print it out here, and we can see it down at the bottom here, like this function returns these scores, and it will print out here the scores it has predicted, and it depends on like how many folds we have divided our data set into. In this case we have 1, 2, 3, 4, 5. So the end folds is 5 in this case, and we have trained our model on 5 different kind of data sets, where each data set has had like the random the rows in the data set, they were randomized, and moved around, so it wasn't the same data it trained on, but it still like got a mean accuracy here of 95%. We also have some other functions here where we just calculating like the mean and standard deviation, stuff like that. So it's just like kind of more math and really like intuitive, and just like it's just like to code it out. So it's not really like that important regarding like how classifiers and stuff like that that works. So if we go down to the next function here, we have like the prediction function, like how we can predict the class for a given row in that we give it. And then up here we have created a function that could calculate like the probabilities of a class occurring in that row. So we just say like the probabilities here is equal to that. And then we have like a for loop here that has a class value and probability, and then we're going through all the items in the probabilities up here. So we just kind of like we go through all the a possibility in all the possibilities there is in our data, and if the best label is none or the probability is better than best prob, then our best probability is equal to the probability, and our best label is equal to the class value. So we have predicted the class for the given row, and we just like return the best label, which is like the class that has been given like the best score, and we return that. So regarding like the naive Bayes algorithm, we create also a function where we give it our train set and our test set. So we want to evaluate like this is like how we call our naive Bayes classifier, and we just like have like summarize here summarize by class on our train set, which is just another function we just skipped, and then we have an empty list here with our predictions, and then we go through all the rows in our tests, and the output will be equal to the predict function that we just created up here, where we pass this summarize and the row, and then the output will then be the prediction that our naive Bayes algorithm or like classifier it predicted, and then we just return all the prediction it has predicted on the data set, like on the test set, and after that trained on the training set. So to like call these functions here in like some kind of our main program, we just like give it the file name here with our data set, and then we convert the last column to an integer instead of to a float instead of a string, and then we also like convert the class column here to integers. So to evaluate the algorithm, we first had to give it like the end false, so like how many different like data sets do we want to split our data into, and then our scores will be evaluated by this algorithm function here, where we give it our data set and our naive Bayes, which is the function up here, and then our how many folds we are dividing our function into, like our data set into, and then we just print out the scores that this function here returns, and then the mean accuracy, where we just calculate the mean accuracies of these scores that has been returned. And as we just printed out here, we can see that the score is printed out here for a model, so like they're pretty consistent, and they're like the mean accuracy is 95%. I'll just try to like print it a couple more times, but if we for example change this end false here to 10, let's say, then we get some other we can see here that we get more scores here because we have divided our dataset into more smaller datasets, and we get other like scores here for each individual test we have made on our model, and then the mean accuracy is then again calculated. So we're now created a model that we can do some predictions on Aries flowers, and if we go into here to the new file here, I have just made this naive Bayes classifier a class here, a module. So I just imported all the functions that we need to use here in this file. So it is just like more a prediction file, but we still do the same up here as in the last file here, where we just start with our dataset, like taking our dataset from a CSV file and converting it to a list, like a dataset list here in Python, and then doing our modifications on them. Then we can create this variable here, model, which will store the model that we have trained in the file in here. So our model will be stored in this variable here, and we just get it from the other file, like with this summarized by class, and then on the data set that we have created. And then we need to define a new record that we want to try to predict on what it is. So we have these 4 features here as in the data set. So each row contains these 4 features, and then we want to predict the category or like the kind of iris it is. So these are just some random values that we want to like try to predict what kind of iris flower this is. So let's get to the fun part here, where our label, which is like the label that we predict, will be equal to the predict function here that we just import from the need-based classifier other file here. And then we give the parameter the model that we have trained, and then the row that we want to do a prediction on. And then we just print out the data and the predicted value that we have predicted with our model. So let's get to the fun part here, and if I hit Control B, we'll do the prediction. And we can see that first we get all the scores that our model has that has trained on, like the accuracy score here. So the mean accuracy is 95.3%, and then our model it was given this data and it predicted the number 2. So the number 2 corresponds to the iris versicolor category. So let's go into the data set here and see if there's some correlation. So if we say, for example, we have 4.1 here, 4.7 here, and 3.2, and then we had 2.3, and we have here like 1.6. So this is not like really close to, and this, oh, it's the TOSA. I'm looking at the TOSA. If we go down here, we can see 4.7, let's say 5.6 here. It's kind of close, and then 2.9, and we had 2.7, 3.6, and we had 3.5, and 3.1, and we had 1.5, so 4. So they're pretty close, these values here. And then it's also like a versicolor. So our model is like kind of good, and it predicted like the versicolor here. If we go up here and, for example, let's just take this iris setosa here, and we go into a model here and change the row. So we want to do a prediction on this data here, and we just like kind of change it up. So it's like 3.1 and 0.1 and 1.8, let's say that, and we hit Control B. Let's see where it now predict. So now it still predicted 2, but now 2 corresponds to the TOSA. So our model again predicted correct, and it will like if these features just give some kind of sense, and they're like trained, like and our model is trained on these data, like it will predict the iris like category, or like the iris with 95% accuracy every time. So if you just hit Control B again and see if it still predict the same, we still predict the soda color here, like the category here, and we do it again, it's still setosa, still setosa, still setosa. So it's a pretty good model, and we have created like our naive-based classifier, and it's just like kind of like more the basic classifiers there is inside of artificial intelligence. But it's good to like get started, and as I said in the start of the video, like some of the like the concepts and functions, they can also be like converted or like used in other classifiers as well. So this is like more like there's like the way of making a classifier where you have a data set that you split into like folds, where then each row of the data set, or like the features, like they're mixed around randomly, so the model is not trained on the same data. And then we split our data set into like a training set and a test set, so we're not testing on the same data as we're training. So because like the model, it should be able to predict on values that it hasn't seen before, which is in this case where we can just go in here and change our values, and it will still like predict it really good and very accurately. So yeah, it's a pretty nice model we have created here, and I just wanted to go more in depth with them compared to the last video where we just did it as a hello world program, and we just took the code and did a prediction fast. But that's pretty much it for this video, guys. Remember to hit the subscribe button and bell notification on the video, and also like the video to show the YouTube algorithm that you like this content and you want more of it in the future. We've created a pretty nice model here that works really good and has a pretty good accuracy, and it's also nice to just play around with these classifiers and try to define new records and play around with the features and see if your model can do different kind of stuff and like how good it is. So this is like just introduction to artificial intelligence, and there's like a lot and tons of different kind of things you can do inside of artificial intelligence. So I hope you'll like follow along in this tutorial and also my other tutorials in computer vision, algorithm and data structure, and also my C++ tutorial. If you're not like familiar with the like basic concept of programming, I have a Python programming tutorial, and I'm doing a C++ tutorial now. So you can get started with programming and also like be able to do these nice and like just amazing things in the future. So I'll link to one of them up here, or else I'll just see you in the next video, guys. Bye for now.